Hello everyone, this is the famous question from HC verma in rotatory motion. The door of an almirah is 6 feet high, 1.5 feet, 5 feet wide and weighs 8 kg. The door is supported by two hinges situated at a distance of 1 feet from the ends. Then we need to find the force exerted by those hinges on the door. So let us try doing this question. So basically the given information is door is 6 feet high and 1.5 feet, 5 feet wide and weighs 8 kg. So we have the door like this, looks something like this. So the given information is 6.5 feet high and this is around 1.5 feet and the weight is 8 kg. So it might be exerting a downward force mg, which is of 8, where m is 8 and g I'll be taking it as 10. So this is one hinge on this side and this is another hinge. So what's given? The door is supported by two hinges situated at a distance 1.5 feet from the ends. 1 feet from the ends. So this is 1 feet. This is 1 feet. So here it's 6 feet totally. So 2 feet we have covered here. So this might be actually 4 feet. So now what is he asking? The forces exerted by hinges. First of all, let us calculate all the forces acting. The first main force is, according to Newton's third law, if the door is exerting force on the hinges, so the hinges will also obviously exert a force on the door. So maybe this force is a vertical force. I'll be calling it as Fv, and this is also Fv, which is being exerted by the hinges on the door. So both are in same direction, so I can write the first equation 2Fv equals to mg. So basically 2 into Fv equals to 80, Fv equals to 40 Newton. So the 40 Newton force is acting upwards, 40 Newton. Now when I try to open this hinge, this one, the door tries to rotate in this manner, in this direction. So torque will be acting on the door due to this mg force about this axis. This is where the torque acts. But initially the hinge is there, so the hinge is also providing a torque in order to prevent the door from rotating it like this. See, if the hinge was not there, the door would have rotated in this direction, but the hinge is providing a horizontal force over here. So same is the case here also. This hinge as well provides a horizontal force to balance it, or else if this hinge only provides the force, the door would have rotated like this in this direction. So let me call it as FH and FH. Now let us consider, since this FH is helping to balance the torque produced by the weight over here, so we will be writing the torque equations respectively, and the door might be rotating about this axis if we will have opened this particular hinge. So FH, we know that torque, the formula for torque is force into perpendicular distance. So the perpendicular distance over here, I'll be taking it as 4 feet, because from the axis it will be 4 feet. So I'll be writing the torque equation 4 into FH, which equals to, now this mg will also create a torque same about this axis. Since this is 1.5 feet, I'll be taking it as around 0.75. So which equals to mg into 0.75. 0.75 can be written as 3 by 4. So F horizontal equals to 80 into 3 by 4 into 4. 4 20 times, 4 5 times, which equals to 15 newtons. So the 15 Newton force might be acting in this direction. So I got the force acting here, which is 15 Newton. So basically this is the force, 40 Newton here and 15 Newton here, 15 Newton over here. Same is the case here. 40 Newton here, 15 Newton over here. But what is he asking is force exerted by the hinges on the door. Like actually the question was force exerted by this hinges is equal in magnitude. So what we have to find is the resultant force acting on the hinges. Yeah, so resultant force acting on the hinges will give us the force exerted by hinges on the door. So each hinge will exert this F resultant, whatever is there. He didn't ask the total force exerted, he asked only the force exerted by each hinge. He wanted to ask actually. So F resultant will be by the laws of vector addition. This will be 40 whole square plus 15 whole square. So which will be about 43 newtons. So this is the force exerted by the hinges. Thanks for watching.